Exercise 1. Gecko moves from left to right along its axis from an initial position xi equal 20 cm to a final position xf equal 100 cm. It takes the Gecko 10 seconds to cover this distance. So sketch the reference system OI, draw the position vector when the Gecko reaches the final position. So now sketching the reference, this means that we have to show the origin, and we have to draw a horizontal x-axis, and we have to show the unit vector I vector. So on your copybooks you can take every one box is equal to I vector, then define that the magnitude of the I vector is 20 centimeter. You have to define this is the scale actually. Now draw the position vector when the Gecko reaches the final position. So let's now locate the initial position and the final position, then represent the position vector or the final position vector. So xi is 20 centimeter. This means that 20 centimeter away from the origin. So it's going to be at this point. And the final position is equal to 100 centimeter. This means 100 centimeter away from the origin. So if we have that I vector is equal to 20 centimeter, then xi here 20 centimeter away from the origin. Now the second vector, we obtain that it is 40 centimeter away from the origin, 60 centimeter away from the origin, adding 20, 80 centimeter away from the origin, 100 centimeter away from the origin. So this is x final. Alright? Now draw the position vector. The position vector by definition is the vector that joins the origin of the reference system to the point at a specified position. So it is this red arrow I'm showing. I did not draw it on the x-axis. I drew it above just to show it to you so that the vectors do not overlap. But actually it is represented on along the x-axis. Okay. Now determine the distance covered by the Gecko. The distance, as you can see, if you count here, 1, 2, 3, 4. So we have 4 unit vectors times 20, so this is 80 centimeter. If I want to think about it graphically. Now by definition, for one-dimensional motion, for one-dimensional and one-directional motion, and when I have an object moving, for example, only along x-axis, and in one direction, in the positive sense, for example, or in the negative sense all the time. So its distance is equal to x final minus x initial. In this case, it's 100 centimeter minus 20 centimeter equal 80 centimeter. Now determine the displacement of the Gecko. The displacement is a vector quantity. That's why it's not enough to only give the magnitude of the displacement. You have to express or to give the vector expression of the displacement. So again, refer to the graph, to the figure here. How many vectors? By definition, the displacement vector is the vector that joins the initial position of the motion to the final position of the motion, by definition. So it is this long blue vector here. So if we consider it like a puzzle, if you think about it like a puzzle, how many unit vectors fit in this long displacement vector? We need 1, 2, 3, 4 I vectors to fit in this displacement vector. That's why we express it as d vector equal 4I vector. Now as for the magnitude, we have that 4I vector as a magnitude, it's 4 times the magnitude of the unit vector. So 4 times 20 centimeter is 80 centimeter. In this case, because it's one-dimensional and one-directional, we obtain that the magnitude of the displacement vector is equal to the distance covered. But this is not a rule, okay? So only here for one-dimensional and one-directional motion, we obtain that the magnitude of the displacement vector is equal to the distance covered. Finally, calculate the average speed of Gecko in centimeter per second and in meters per second, and deduce his average velocity. The average speed is equal to the total distance covered over total time, over the duration. So it's 80 centimeter over 10 seconds. Okay, so it's 8 centimeter per second. Then in meter per second. Now we need to convert from centimeter per second to meter per second. In this case, there is only one unit conversion, which is the conversion of the unit of distance from centimeter to meter. And we don't have to convert the unit of time. That's why we only multiply, or we only draw multiply by one fraction here, one bar fraction. Now we have the centimeter in the numerator, we write it in the denominator, and we fill in the other part by the new unit. So we had centimeter in the numerator, we write it in the denominator, and so we fill in the other one with the new unit. Comparing meter and centimeter, we have that meter is greater, so we write 1 beside meter, and 1 meter is equivalent to 100 centimeter. Now we simplify the unit, centimeter cancels with centimeter, so we're left with meter per second. 8 over 100 is 0.08 meter per second. So now deduce the average velocity. The average speed is the magnitude of the average velocity. And since here it's moving in the positive, or in the positive sense, in the same sense of I, so we can say that the average is equal to speed I vector, yani 0.08 I vector, positive.